Hey everyone! In this video, we are going to be solving a 2D inelastic momentum problem. So we're going to get the key information. A 1680 kilogram car is driving 20 degrees east of north at 25 meters per second. It strikes a 2400 kilogram truck that was traveling 20 meters per second at 60 degrees west of north. We have two directions, that's two things. After the collision, they stick together. That's what means it's inelastic. It's inelastic because they've stuck together. They didn't bounce. At what velocity do they slide away? The first thing that we have to do here, though, is adjust those directions. We've been given cardinal directions, so norths, easts, souths, and wests, which don't work quite so well in our equations. So we're going to convert those into standard angles, which are angles from the x-axis. Our first little one here is 20 degrees east of north, so we north, shift it over. That's a standard angle of 70 degrees as a rotation from the x-axis, a rotation from east. And we can go ahead and mark that up top just so that we can see that. Our second direction is 60 degrees west of north. So again, if you can do this in your head, that's fine, but I'm just going to draw a little diagram at 60 degrees west of north. If that was a rotation all the way from east, it's 90 to north, 60 more, so that's 150 degrees from the x-axis. And we can go ahead and mark that one down as well. Now we have masses, we have velocities, we have directions. We're ready to solve this momentum problem. I think what we're going to do here is we're going to scroll that up. And let's do x momentum first. Like all 2D momentum problems, you have to solve the x momentum and the y momentum separately, and then do a right angle triangle at the end. Our equation is the same, m1 v1 cos theta 1 plus m2 v2 cos theta 2. Now, here's the difference between elastic and inelastic collision. In inelastic collision, you simply add the masses together, m1 plus m2, and the x component of our velocity. It's actually a little bit nicer than the elastic collisions. We can fill in these values that we know from the question. We know the mass of the car, we know the velocity of the car and the direction it was going, we know the mass of the truck, we know the velocity of the truck, and we know the direction it was going. And this is going to equal the combined mass of both vehicles, which we can add those together, get 4,080 Vx. If you've got this far, you can clean this up in your calculator. You're just going to chug out those numbers on the left-hand side. It's going to equal negative 27,204.37. That's going to equal, still on the right-hand side, our 4,080 Vx. To get Vx all by itself, we divide both sides by 4,080, leaving us with negative 6.67 meters per second. We're going to the west. We're sliding to the west. That's what that negative means. Now let's go ahead and do our y momentum. Like I said, in 2D momentum problems, you have to do your x momentum, and then you have to do your y momentum. You need both of them. But the equation's almost identical. We just swap coses for sines. So it's m1 v1 sine theta 1 plus m2 v2 sine theta 2 is equal to their combined mass multiplied by our y velocity component. Once again, we can fill those in. We know the mass of the car, we know the velocity of the car, and we know the direction it was going. We're going to add that to mass 2, that's the velocity of our truck, that's the mass of our truck multiplied by the velocity of our truck multiplied by the angle it was going, and that equals their combined mass multiplied by our y component. That's the up-down direction, the north-south direction that they're going to slide. Everything that's on the left can be plugged directly into your calculator to get a term. We can simplify this to get it equal to the 4,080 Vy, divide both sides by 4,080. Vy is 15.55 meters per second. We're sliding north. The Vx component is negative, it's going to be west. The Vy component is 15.55, it's going north. It's time to draw a little triangle and figure out what our final vector is going to be. I put a big circle where I'm starting, that's why I don't forget. I move to the left, 6.67. We're going to move up, and this time it's 15.55. We want to get that hypotenuse. Oh, 2D physics is all about the triangles. It's all about the triangles. We can do Pythagorean theorem. The c squared equals the 15.55 squared plus the 6.67 squared. We can go get ourselves a little 8th grader to do this for us. This part's easy once you get this far. The c squared is going to equal 286.47. We take the square root of both sides. It's 16.9 meters per second. That is the speed at which they are sliding, but we need the direction. We gotta know the direction at which they're sliding. It says right angle trig, so we can use tan theta. There's our little theta right there. We know the opposite, we know the adjacent. Tan of theta is our opposite, 15.55, over our adjacent, 6.67. We hit the inverse tan button and we get a theta equal to 66.8 degrees. We got it. We have a velocity, we have a direction, but we're going to have to report this angle, in this case, as 66.8 degrees north of west. So west is straight over, and we rotate it up a little bit, so that's 66.8 degrees north of west. If you feel more comfortable, you can convert that angle in this case into a standard angle because it's a rotation back from 180. So you could do 180 minus 66.8. That's a 113.2 degree standard angle from the x-axis. I suppose it depends on who your instructor is and how fussy they are. In my case, where the question gave it in cardinal directions, I will be happy accepting it back in cardinal directions. Our final answer is 16.9 meters per second at 66.8 degrees north of west. And just like that, we were able to solve a 2D inelastic momentum equation. Inelastic, the two objects stuck together after the collision. I hope this was helpful, and if you have any questions, feel free to leave them down in the comments below. Otherwise, I'll be looking forward to seeing you next time.